The Celona Network Planner is a free online tool that provides the capability of estimating the CBRS network resources required for a specific location. It's available free online. Just go to planner.celona.io. In this demo, I'll show you how the network planning tool supports the initial design phase, particularly around coverage and capacity planning for CBRS LTE networks. The key criteria we'll cover includes the spectrum availability at the location, the coverage area, whether that be square feet or something we draw on the map, and the capacity required based on the number of simultaneous active users. So first, we start with an address. We're going to pick one close to home for me. It is a carpeted office scenario we're going to go with here. Incidentally, these are the old Borland offices in Scotts Valley. So we have 50,000 square feet we need to cover. Now you can already see we've got some information populated here. This is the frequency that's available. This has been gathered from a live query to the Spectrum Access server. So that is a real-time view of what spectrum is available at that location. We chose carpeted office. Now each of these different facility types have different parameters in the background in terms of how the coverage and capacity is calculated. So it is important that you choose something that is physically like the location you're deploying in. We're choosing square foot. We're going with 50,000 square feet. We're going to deploy approximately 40 devices. These are all CCTV cameras, so their duty cycle is 100%. They are always streaming data to the CCTV server. We're doing full HD, medium quality, 10 frames per second, which is pretty normal for a CCTV spec. Obviously, you can adjust these as much as you want. You could also create a custom application, but in this case, we'll go with IP cameras. So you can see, in order to provide coverage for 40 cameras online all the time, in that square foot area, we're looking at approximately two Celona APs. It's also possible to simulate what would happen if someone with a PAL license came into your area. So you can take away perhaps the spectrum that they may be using, and you can see with 50 megahertz, our AP count is still 2 devices. Now, if we went for a slightly different layout, so we wanted to estimate based on user devices, let's just say we went to 600 devices that are being carried by users, we would create a custom app. On average, they're doing 10 down, 2 up, and a 30% duty cycle. And you can see that we have 6 APs here. If I make changes to the spectrum, if there's more spectrum available, we can reduce our AP count. So this really allows you to do some what-if scenario planning. So the Network Planner tool allows you to do some what-if planning, both looking at the real-time what-if available frequency you have today. So we covered number 1, the spectrum availability based in that location. And we've done it based on the physical location from a map. You could also enter coordinates from lat long. We have the coverage area, 50,000 square feet, and it's a carpeted office. And then the capacity requirements we've entered below. And you can see how you can mix and match all of those different inputs to get a good analysis of what you would need to do to deploy a CBRS private LTE network in your chosen facility. Thank you. So now that we've completed the planning and design phase in the Celona Network Planner, let's go ahead and deploy a network using the Celona Orchestrator Network Automation Platform. So when you first log in, you'll be presented with a view of all of your sites that you have configured, all of the traffic, in that case, from the previous 24 hours. You see we've got a demo network already configured on this particular orchestrator. We'll go ahead and we'll add a site based on the parameters we put in the planner. So we've got the same location, and you can see, again, the system has undertaken a live query to SAS, and we have that spectrum available. So we'll call that Scotts Valley CA. When it comes to access points, if the correct number of access points have been assigned to your orchestrator, they are selectable here. So you would go through, and I think we had 2 APs assigned to this. We would select 2 of these Celona APs. We would also select whatever edge nodes were assigned to our site, and it would be a single edge node to support the capacity for the CCTV that we spoke about. We can save that site. Next step, we go to devices, and we can let's just assign some SIMs to that site. We select them there, click activate, say which site we want to assign them to, and activate. That's it. Those SIMs are now active for any users on that site. Now, because we may have different applications running across the network, it's sometimes good to create a specific device group. At the moment, you see all of the SIMs are activated in the default device group, and these device groups are global, so you can have them across multiple sites. So we will call this the CCTV uplink device group. We're sticking with the same domain name, but that will cover in a different demo, and we will select the 3 SIMs to be a part of that device group that we had in the previous page. So there we go, we have our devices, device group. Let's configure an application. As we mentioned, it's a CCTV application. I already have one here, but I'll create a new one just so you can see. Upload. Now, when it comes to creating an application, we can identify that application using any of these parameters. The source, destination IPs, ports, and including DSCP tags. So we're going to use the source, the destination IP, and the destination IP of the network video recorder is 10.20.0.1. Oh, there you go. You do have to add the mask, and you can make it a range, or as you can see here, we've made it a /32 single IP address. So that is now added as an application in the system. So we created the application. The next step is to create a microslice. Now, microslices provide quality of service on a per application basis. So it's not per device, it's per application. We are doing a CCTV uplink, as we said before. We want a guaranteed bitrate. Now we're going to set this to 5 megasecond uplink because we may decide that we want to do a 4K video or very high frame rate, 30 frames per second, for example. We don't need any down because the cameras don't need a guaranteed stream on the way down. And we can select from a number of quality of service classes. With this one, we want pretty low latency. It doesn't have to be full real time, but we'll go for interactive video, which you can see is 150 millisecond minimum in terms of, maximum for the latency. We configured a device group before, the CCTV uplink, and we also configured an application, CCTV upload. There we go. And save the site. And we have created a site now. We have activated SIMs for that site. We created device groups, created applications so that we can specify which applications we need QoS performance on, and we created the microslice. So now we have an active network. Let's have a look at a microslicing demo. So now that we've deployed our network and used the Celona orchestrator to configure a microslice for video, let's look at microslicing in action from a demo we've recorded earlier. So let's go over what we're looking at here. In the top right-hand corner, we have live video stream coming from an IP camera behind a Cradlepoint AER2200 gateway. It's 1080p, 30 frames per second. You can see pretty high bitrate video. This is the microslice. So in the top right, this is the microslice video. The video below that is coming from a Zebra ruggedized tablet. Again, we're sending 1080p, 30 frames per second. We're on the LTE network natively with that device. And as you can see right now, we're monitoring those traffic flows using NTOP and that's showing us that both are proceeding no problem at all. Video's working great. We've got no issues on the network. Now, we'll introduce some congestion using iPerf from an iPad Pro in around about 10 seconds, and you'll see some changes here. This is the buffer. That will lose some data. Frame rate may drop, bit rate may drop. And you can see that that just happened as the iPerf traffic started, and you can see in NTOP here is the iPerf happening. It's only been going for a few seconds. And you can see that the unprotected video is fluctuating wildly. It's stuttering, we're getting some pixelation, we're losing traffic in the buffer. We're seeing frame rate drops down at 18, 16, 15 frames per second. Meanwhile, the MicroSlice video is working perfectly. No issues there whatsoever. We're maintaining our frame rate, our bit rate, no degradation in quality whatsoever. So that is MicroSlicing in action.